Now, in the question 8, a class has 30 girls and 15 boys. Two representatives are to be selected at random from the class. In the part 1, draw a tree diagram to show the probabilities of the possible outcomes. So, first we will see we have number of girls is equal to 30, number of boys is equals to 15. So the total number of students will be equals to 30 plus 15 is equals to 45. Now we have to draw a tree diagram. So in say we have two possibilities. For the first student we have a girl and a boy. So we have to select two representatives at a time. So first student may be a girl or boy, and this is the probability for the first student. From girl we have further two possibilities, and from boy we have further two possibilities. So in total it has four possibilities, girl and boy. Now this is for the second student. Now we are going to find out the probability that will occur at the end of each branch. So for the girl to be a first student, the probability will be 30 over 45, and after simplification it will give this 6 over 9, and more simplification it will give us 2 over 3. Now for the boys we have 15 over 45. After simplification it will give us 3 over 9, and after further simplification it will give us 1 over 3. So it will be equals to 1 over 3. So the probability that the first student to be a girl is 2 over 3, and a first student to be a boy is equals to 1 over 3. Now for the girl, since we have already selected one student, so 44 students left. So here we have 44 students left in each case. Now to find out the number of girls, here we have 30 over 44. Now in the case of boys, it will be 29 over 44, and it will be 30 over 44. And it will simplify 15 over 22. Now in the case of second student to be a boy, the first student is girl and a second student boy, the probability will be 29 over 44. And in the case of girl to be a second student when the first student is also a girl, the probability will be 29 over 44. And here we have 15/44. So this is the tree diagram. Show the probabilities of all the possible outcomes. Now in the part 2, Albert said that the probability that a boy and a girl are selected as representative is, so the probability according to Albert that a boy at first place and girl at second place. So from the tree diagram that a first is boy, the probability is 1/3, and the second is girl, and the probability is 15/22. So after simplification, it will be equals to 5/22. So this is the probability that Albert has calculated. He did not take into an account that there are two possibilities. The first possibility the first is boy and second is girl, and the other possibility is the first is girl and the second is boy. So that's why Albert has calculated the probability incorrectly. Now in the part 3, find the probability that the first representative is a girl. So from the tree diagram, we can see that the probability that the first student is a girl is equals to 2/3. Now in the part B, the second representative is a girl given that the first representative is a boy. So we have to find out the probability that second is G given that the first is boy. So second is the girl and the first is boy. So here we have the probability 15/22. So the probability that the second is G given that the first is boy is equals to 15/22. Now in the part C, we have to find out the probability that the first representative is a boy and the second representative is a girl. So here we have used the word and, so we will apply the multiplication law of probabilities here. So from the tree diagram, we have to find what is the probability if the first is B. So here we have the probability 1/3 if the first is B multiplied by, and the second is G. So for the second is G, we have the probability 15/22, and after simplification it will becomes 5/22. So the probability that the first is B and the second is G is equals to 5/22. Now in the part D, find the probability that a boy and a girl are selected as representative. So the probability that a boy and a girl are selected, we have two possibilities. There the first is boy and the second is girl, plus, and the first is girl and the second is boy. So from the tree diagram, first we will apply the multiplication law of probabilities here, and from the tree diagram we can write down the probabilities. If the first is boy, then we have 1/3 multiplied by, and if the second is girl, then we have 15/22, bracket close. Add the probability if the girl is first, so 2/3 multiplied by, if the second is boy, so we have 15/44. Now after simplification, it will give us 5 over 22 plus 10 over 44. Now we will take the LCM here of 22 and 44. 22 ones are 22, 22 twos are 44. Now we are taking the LCM of 22 and 44. So here we have 11 twos are 22 and 11 fours are 44. So we have 2 ones are 2 and 2 twos are 4 and again 2 ones are 2. So 2 multiplied by 2 multiplied by 11 gives us 44. So the LCM is 44. So here we will apply the butterfly rule. 22 twos are 44. So here we have 5 multiplied by 2 plus 44 ones are 44. So here we have 10 multiplied by 1. Now we have 5 twos are 10, add 10 over 44 and it will be equals to 20 over 44, and after simplification we will get 10 over 22, and after further simplification we have 5 over 11, so it will be equals to 5 over 11. So the probability that a boy and a girl are selected is equals to 5 over 11. Now in the part E, we have to find the probability that the second representative is a girl. So in this case, we have two probabilities, that if the first is boy and the second is girl, plus if the first is girl and the second is also a girl. So here we will apply the multiplication law of probabilities. So from the tree diagram, the probability if the first is boy, we have 1 over 3, and if the second is girl, we have 15 over 22. Now plus the probability if the first is girl, then we have 2 over 3, and the second is girl, then we have 29 over 44. Now we have, now after simplification we have 5 over 22 plus 29 to the 9 to the 18 as a 1, 2 to the 4 as a 5, 58 over 132. Simplified to 29 over 66. So here we have 5 over 22 plus 29 over 66. Now we are taking the LCM of 22 and 66. So here we have 11 2 is a 22 and 11 6 is 66. So now we have 2 1s are 2 and 2 3s are 6. So here we have 3 1s are 3. So 11 multiplied by 2 multiplied by 3 gives us 66. So the LCM will be 66, and by using the butterfly rule, 22 threes 66. So 5 multiplied by 3, add 61 6 ones are 66, so we have 29 multiplied by 1. Now we have 5 threes are 15, add 29 over 66, and it will be equals 29 add 15 will be 9, 14 and 1, 44. So here we have 44 over 66, and after further simplification GG. Now after simplification we will get 2 over 3. So Here we have 2 over 3. So the probability that the second is girl will be equals to 2 over 3. Now the probability that the second is girl will be equals to 2 over 3. Now in question 9, 5 balls numbered 1, 2, 5, 8 and 9 are put in a bag. In the part 1, one ball is selected at random from the bag. Write down the probability that it is numbered 8. So now in the part 1, we have to find out the probability of numbered 8, and that will be equals to number of favorable outcomes divided by number of total outcomes. Since we have 5 balls, so the total number of outcomes in this case is 5, and 8 comes only once, so the number of favorable outcomes is 1 over 5. So the probability that it is numbered 8, the ball is numbered 8, is equals to 1 over 5. Now in the part 2, on the other occasion, 2 balls are selected at random from the bag. By drawing a tree diagram, find the probability that in the part A, the number on each ball is even. So first we have to draw the Venn diagram. Since we have 5 numbered balls, and the numbers are 1, 2, 5, 8 and 9. Now this is for the first ball. Now for the second ball, from 1, we have 4 branches. We have already taken the number 1, so we have numbers left 2, 5, 8 and 9. Now from number 2 we have further 4 branches, and so since we have already selected that number 2 ball, so the numbers we have left with are 1, 5, 8 and 9. Now from 5 we have also again 4 branches. We have already taken the ball numbered 5, so here we have 1, 2, 8 and 9. Now for the number 8 we have 4 branches. We have already selected the numbered 8 balls. Here we have 1, 2, 5 and 9. Now from 9 we have again 4 branches. We have already selected the ball numbered 9, so here we have 1, 2, 5 and 8. So now the number of possible outcomes from the tree diagram is equals to the 4 multiplied by 5, and that will be equals to 20. Now in the part A we have to find out the probability that both numbers are even. So for this we have the probability of the order pair 2 and 8 plus the probability of the order pair 8 and 2, and here we have the probability for 2 and 8, and that will be 2 and 8, so it will be 1 over 20. Similarly for 8 and 2, so we have 1 over 20, and after adding up we will get 2 over 20, and after simplifying we will get 1 over 10. So the probability that both numbers are even is equals to 1 over 10. Now in the part B we have to find out the sum of the numbers on the balls is more than 10. So here we have probability of 2 and 9 plus probability of 5 and 8 plus probability of 5 and 9 plus probability of 8 and 5 plus probability of 9 and 2 plus probability of 9 and 5 plus probability 8 and 9 plus probability of 9 and 8. The probability of all these ordered pairs is 1 over 20 plus 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 1 over 20 1 2 3 4 5 6 plus 1 over 20 plus 1 over 20 8 times, and it will be equals to 8 over 20. Now after simplification we have 4 over 10, and further simplification gives us 2 over 5, and it will be equals to 2 over 5. So the probability that sum of the numbers is more than 10 is equals to 2 over 5. Now in the part C, we have to find the probability that the number on each ball is not a prime number. So for this we have the probabilities of order pair 1 and 8, both are not prime numbers, plus 1 and 9 plus 8 and 9. So we have plus 8 and 1 plus. Now the probability of 9 and 1 plus probability of 9 and 8. Now we have the probability 1 over 20, in each case 1 over 20 6 times, 1 over 20 plus 1 over 20 plus 1 over 20 plus 1 over 20. Now we have 6 over 20, and after simplification it will become 3 over 10, and it will be equals to 3 over 10. So the probability that number on each ball is not prime number is equals to 3 over 10. Now in the part D, we have to find out the probability that only one ball bears an odd number. So for this, we have the probability of order pair 1 2 plus probability of order pair 1 8 plus probability of 2 5 plus probability of 2 9 plus probability of 5 8 and plus probability of 8 9. Now we have plus probability of 2 1 plus probability of 8 1 plus probability of 5 2 plus probability of 9 2 plus probability of 8 5 and plus probability of 9 8. Since we have 1 2 3 4 5 6 7 8 9 10 11 and 12 probabilities, and each probability is equals to 1 over 20, so in total we have 12 over 20, and after simplification it will become 6 over 10, and further simplification gives us 3 over 5, so it will be equals to 3 over 5. So the probability that only one ball bears an odd number is equals to 3 over 5. Now in the question 10, a red die has the number 1 on the 1 face, the number 2 on 2 faces, and the number 3 on 3 faces. Two green dice each has the number 6 on 1 face and the number 5 on 5 faces. All the dice are fair. The 3 dice are rolled together. In the part 1, copy and complete the tree diagram by writing the probabilities on the branches. Since the red die has 6 faces, since in the case of red die, the red die has 6 faces, the number 1 is on one face, and die has 6 sides, so the number of total outcomes is 6 in this case. Now the number of favorable outcomes from the question. The number 1 is on one face, so the probability for the number 1 is 1 over 6 in the red die. Now for the number 2 is on 2 faces, so the probability of the number 2 comes on the red die is 2 over 6, and that will be equals to 1 over 3. Now for the number 3, number 3 appears on the 3 faces, so the number of favorable outcomes is 3, and it will be equals to 1 over 2. So the probability that the number 3 comes on the red die is equals to 1 over 2. Now in the case of first green die, okay, two green dice each has the number 6 on one face. So for the number 6, here in each case the number of total outcomes is 6, just because dice has 6 faces. Now for the first green die, the number 5 appears on the 5 faces, so the probability for the number 5 to become on the first green die is 5 over 6. Now for the number 6, number 6 is only on one face, so the number of favorable outcome is 1, so here we have 1 over 6. Similarly, we have 5 over 6 and 1 over 6, 5 over 6 and 1 over 6, and same things repeat for the second green die, and we have 5 over 6, 1 over 6, 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 5 over 6, and 1 over 6, just because in the case of green die we have number 6 on one face only and number 5 on 5 faces. So this is the complete tree diagram showing the all possible outcomes. Now in the part 2, using the tree diagram, calculate the probability of obtaining in the part A 2 on the red die, 5 on the green die, and 6 on the second green die. So for this, we have the probability 2 on the red die, 5 on the first die, and 6 on the second green die. So for 2, we have the probability. By using the multiplication law of probabilities, we can get the probability of 2 on the red die. So here we have 1 over 3 multiplied by, now for the 5 we have the probability 5 over 6 multiplied by, now for the number 6 we have 1 over 6, and over part is like this, from 2 on the first die, on the second we have 5, and on the third we have 6. Now after multiplying we get 5 over 18, 6 108. That 2 on the red die, 5 on the green die, and 6 on the second green die is equals to 5 over 108. Now in the part B, find the probability that 3 on the red die and 6 on each of the 2 green dice. So here we have probability of 3, 6, and 6. By using the multiplication law of probabilities from the tree diagram, for 3 we have the probability 1 over 2 multiplied by, for 6 we have 1 over 6 multiplied by, again we have 1 over 6, So 6 2 is a 12 and 12 6 is 72. So here we have 1 over 72. The probability that 3 on the red die and 6 on each of 2 green dice is equals to 1 over 72. And the part C, we have to find out the probability that the probability of exactly 2. Now the probability of exactly 2 sixes is equals to probability of 166. Here we have three possibilities. Probability of 266 plus probability of 366. So from the tree diagram and by using the multiplication law of probabilities, for 166 we have 1 over 6 multiplied by 1 over 6 multiplied by 1 over 6. We will highlight the path with red for 166. Now for 266 we have 1 over 3 multiplied by 1 over 6 multiplied by 1 over 6. Add. Now for 366 we have 366. So here we have 1 over 2 multiplied by 1 over 6 multiplied by 1 over 6. Now we have 1 over 210. Add. 1 over 108 plus 1 over 72. Now we have taken the LCM of 216, 108 and 72, and after multiplying all these factors we get 216. Since the LCM is 216, now by using the butterfly rule, 216 ones are 216, so we have 1 multiplied by 1 plus 108 2's is equals to 216. So here we have 1 multiplied by 2 plus 72 threes is equals to 72 multiplied by 3 is equals to 216. So here we have 1 multiplied by 3. Now we have 1 plus 2 plus 3 over 216, and after adding up we will get 6 over 216, and after simplification we will get 3 over 108. After further simplification we will get 1 over 36. So the probability that exactly 2 sixes is equals to 1 over 36. In the part D, we have to find out the probability that a sum of 12. Probability that a sum of 12. So here we have the three possibilities. Here we have 1, 5, 6 plus probability of 1, 6, 5 plus probability of 2, 5, 5. Now from the tree diagram, by using the multiplication law of probabilities, we can write down the probabilities of 1, 5, 6. So for 1, 5 and 6 we have 1 over 6 multiplied by 5 over 6 multiplied by 1 over 6 plus for 165 again we have 1 over 6 multiplied by 1 over 6 multiplied by 5 over 6 plus for 255 we have for 255 we have 1 over 3 multiplied by 5 over 6 multiplied by 5 over 6. Now we have 5 over 216 after multiplication. Again we have 5 over 216, and here we have 25 over 108. Now we are getting the LCM of 216 and 108. So here we have 2 ones are 2 and so 8, so 2 5s are 10 and 2 8. Now we have again 2 5s are 10 and 2 4s are 8. Here we have 2 2s are 4 and 2 7s are 14. Now we have 2 2s are 4 and 2 7s are 14. So here we have 27. Now we have 3. Here we have 9 and 9. Here we have again 3. Here we have 3 and 3, and here we have 1 and 1. So 3 and there's a 3. Now after multiplicating the factors, we get 216 as a result. So now the LCM is 216, and now by using the butterfly rule we have 216 ones is equals to 216. So we have 5 multiplied by 1. Again we have 5 multiplied by 1 plus 108 times 2 is equals to 216. So we have 25 multiplied by 2. Now we have 5 add 50 divided by 216. And now we have 5 add 5 is 10 and plus 50. So here we have 60 over 216. Now we have to simplify it. So here we have 30 and 108, that it will simplify to 108. Now we have 10 and now after further simplification we get 5 over 28. So now the probability that a sum of 12 is equals to 5 over 28. For the simplification we will get 5 over 18. So now we have the final answer 5 over 18. So the probability a sum of 12 is equals to 5 over 18. Now in the part E, what is the probability that a sum which is divisible by 3? So here we have two possibilities. A sum is 12 plus the probability of the sum is 18. Sum is 12 and a sum is 15. Both numbers are divisible by 12. Since in the part D we have find out the probability of the sum is 12, and that is 5 over 18, plus now the probability the sum is 15. So here we have 366. Now from the probability tree diagram for 366, by using the multiplicative law of probabilities, we have 1 over 2 multiplied by 1 over 6 multiplied by 1 over 6, and here we have 5 over 18 plus 1 over 72. Now we are taking the LCM of 18 and 72. So here we have 2 9s are 18 and 2 3s are 6. Now we have 3. So 3 3s are 9 and 3 1s are 3 and 3 2s are 6. Now we have 3 and 3 1s are 3. Now we have the LCM 72. Now we're using the butterfly rule. Since 18 fours is equals to 72, so 5 multiplied by 4, add 72 ones is equals to 72. So here we have 1. Now we have 20 plus 1 over 72, and it will be equals to 21 over 72. After simplification, we get 7 over 26. After simplification, we will get 7 over 24. So the probability a sum is divisible by 3 is equals to 7 over 24.